Welcome back to Spring One's Agile Leadership Track. Next, we have Brendan and James from T-Mobile with Shit's on Fire, Yo, a true story inspired by real events.
Hello, good morning, Spring One. My name is Brendan A. I'm a technical director of platform architecture. Been at T-Mobile for around 10 years now, mostly responsible for Cloud Foundry and Kubernetes architecture.
Hi, my name is James Webb. I'm a member of technical staff here at T-Mobile. I've been here for about 12 of the past 15 years, and my recent focus has been on the same Kubernetes and Cloud Foundry architecture.
James and I kind of have a running joke that normally one of us introduces ourselves. The other one just says, I do what he does.
Yep, who we are. So we're a team that supports basically the modern on-prem container platforms, right? Brendan led the effort to get Cloud Foundry in here even before I'd come back to T-Mobile, and garnered some interest from some executive leadership about how we're going to do digital transformation, and they started with Cloud Foundry, and I was lucky enough to be around at the time and join the team. We are a team of 55 who's grown from 2. So initially it was just Brendan and myself and a third person who's no longer with T-Mobile, but we have grown from 2 members to 55 team members. As you know, it's not really easy to hire Cloud Foundry and Kubernetes platform admins. So instead of going out and trying to find that skill set in the marketplace, we've really focused on providing opportunities for other folks within T-Mobile on technical teams to take on new challenges and kind of transform their skill set into what we think where everything is going, right? These container platforms, and away from more traditional Unix, Windows, database, VMware, other infrastructures, right? So it's been a pretty incredible experience building a team from 2 to 55, and I got to say it's been a lot of fun, and it's very it's great. One thing I will say, and this is a shout out to our intern program, is we've gotten some just amazing candidates, amazing team members through our intern program, and some of those guys are sticking around, and we are very, very pleased with the talent infusion we've gotten through that. We are 55 team members. We do have redundant Joes on the East Coast, and they are geo-distributed. It is kind of a little bit of a risk that they're just on the East Coast, but we're trying to figure that out. We have 4 core teams. One core team maintains our virtual infrastructure, which is about 5,000 hosts, and about 1,100 of those support our Cloud Foundry and Kubernetes infrastructures below. We have 30 Cloud Foundry foundations running up 75 application instances. This is a fairly important platform to the business. Most of our middleware and a lot of our order management and digital facing channels run on the platform now. Our Kubernetes environment's about 90 clusters, 22,000 pods. We've been hovering right around the 100,000 mark for a while. We're going to have a party once we get there. Between these 2 platforms, I know 100,000 pods doesn't sound like a lot, or 100,000 containers does not sound like a lot to a lot of large companies, but for us, it's a pretty big deal, right? These are not workloads that are running ephemerally being spun up and spun down every day. It's more about just a place for our core applications that used to be running on VMs or bare metal or other forms of infrastructure, and moving them to a platform that provides an agile, consistent experience for teams to run their workloads without having to go through all the pain of maintaining their infrastructure like they had to do in the past. So we feel like we provide a valuable service, and our customers seem to think so as well. No, we are just the on-premise team. We also have some partners who run very similar services in the public cloud. We are getting tighter with them every day. So I just want to shout out to them as a big part of our story as well.
Yeah, I think we really can't overstate enough how transformational these platforms have been for T-Mobile. We went from us taking 7 months and 72 steps to get a single line of new code in production to being able to do that now same day through dev, test, prod, and roll back just as easily. And for scale-up activities, same thing. Really all around, this has been a much better experience for us and all of our customers. Our teams are more agile. They have less busy work. Let's keep the lights on work, and they're able to move very quickly and push out new features and value add much more rapidly. So we've got some big platforms. What do we watch? Really, we try to watch all the things. In DevOps, the mentality should be measure everything, and that's something we've taken to heart. We want to collect metrics on almost everything humanly possible, even if we don't know what things are important right now. Metrics could be important later on and could be relevant, and be able to see, what the historic metrics were for the last, 2 days, 12 days, 30 days, 4 months can be very beneficial when you try to identify behavior in a component that previously was running just fine. So we have a lot of these platform KPIs. Every component in the platform should be emitting metrics. This is, kind of par for the course with both Cloud Foundry and with Kubernetes. A large number of interconnected components, and they all have metrics on the performance, their process stats. We try to measure all of that, and we've found a number of those things that are very helpful KPIs that can identify platform problems ahead of actual incidents. We also do synthetic transactions and black box monitoring. Primarily, this is testing user experience. So we have, for example, Cloud Foundry smoke tests that one of our engineers has written and since open sourced, where we're able to test various user experiences where users can log into the platform, push an application, scale it up, scale it down, delete it, test endpoints, make sure it works. Do the same thing for MySQL, for Redis, for Gemfire, for our GSLB service. For any of these services that we run, we have similar smoke tests where we're seeing the end-to-end functionality, making sure that the basic CRUD operations for those services and for the platforms themselves work. And that's been a huge thing for us to be able to see very quickly when a smoke test is failing. That could be something that is impacting user behavior as well. So it's something that we take very seriously, and we try to investigate those as quickly as possible to make sure that we are aware before our customers are that we have some sort of platform level issue. In addition to the higher level platform and synthetic monitoring, we also have basic raw infrastructure metrics on all of our server infrastructure, the virtual layer as well as the network layer. We want to capture CPU, memory, performance. We don't really capture temperature, things like that. Our DC team manages that. But really, making sure the hardware itself is performing as expected, is not overloaded. And if it is, we know about that, hopefully before it causes downstream impacts. Another big thing for us is Slack. We've adopted Slack very early when we deployed these platforms. We have customer channels for both Cloud Foundry and Kubernetes, where effectively all of our customers are members of those channels. We broadcast all of our notifications there around platform upgrades, around any kind of incidents we have, around new features, breaking changes, things of that nature. So we can very quickly interact with all of our customers in one place instead of having to shoot out emails and have people reply all and everyone get fatigued from that kind of stuff and put it in a folder. Slack has been great for us. Because of that, we have customers that report problems very quickly, because that's our primary method to engage with both our on-call as well as the members of our team that are tier 2, tier 3 that are also paying attention to the channel, even if they're not actively responding to customer incidents. So that's generally the fastest way we find out about incidents that we haven't caught with our monitoring is when we see 1 or 2 or 3 customers report similar behavior or chime in on someone else's report. We know pretty quickly what's important and what might be causing issues on our platform. So cannot overstate enough how important Slack has been for our partnership with all of our customers. Finally, we do some application and container monitoring. We try to leave that mostly up to our customers, but we do collect basic container, CPU, memory, disk metrics, as well as application HTTP requests. We try to collect the request size and duration, as well as errors, so that we know what applications are misbehaving. Example of this, we might see a platform KPI for our routing layer showing excessive latency, and that might be a platform problem, might not be, but by digging in on those application level HTTP requests, we can see, for example, this application running in this customer's namespace has a 15-minute response time, is timing out when it hits that, and it's what's driving up the average latency on the routing layer. Even if it's not a platform issue, we can still identify it down to the application level where we see this kind of issues. So we'll be going through 2 different incidents we've seen today, one on Cloud Foundry, one on Kubernetes. This is an example of how we have a lot of customers that have architected their Cloud Foundry apps to be more highly available. So we have at the bottom here, myapp.go.cs.mobile.com. It's an app running in Cloud Foundry that has a geo route that is the same in all 3 of these foundations. We have 3 foundations running across 3 hardware regions, generally across 2 data centers. We refer to this as near, near, far, where due to data gravity, most customers want to run in data center A, but they can fail over to data center B if required. So we have maybe foundation A and B in the first data center in 2 different hardware regions. We'd have foundation C in a separate data center where customers can run active-active or active-passive. And with this methodology, they're able to run capacity where they prefer to in data center A, but also they can run a data center B completely if they really had to, albeit with slightly increased latency. So each foundation has a load balancer in front of it, which presents the bit for the foundation itself. Each of these foundations would have, a foundation a.cf.c.mobile.com type of domain, but that's not really geo available. So we have a GSLB service, which is global server load balancing, which is effectively a DNS-based load balancing methodology with some more intelligent health checks and traffic steering rules. So we've been using GSLB at T-Mobile for quite some time, but typically that's via intake and consultation with our network team. That can take time, and as we move towards a microservice-based methodology, we see those numbers go from 1 or 2 applications for a team to 10 or 20 or 100 different microservices. If each one of those required separate intakes and consultation with network team, as well as ongoing work to make changes to those pools, it would be extremely burdensome to both our customers and to our network team. So we created an open service broker compatible service broker for the GSLB itself. The GSLB in this case is F5 GTMs. So customers in either Cloud Foundry or in Kubernetes can very easily interact with the service broker to create a new wide IP service in the GSLB, to add new regions or new foundations or clusters to that wide IP, and allows them to update that very quickly and easily without ever engaging our network team. So instead of taking a week or two, it now takes a second or two to create that same GSLB service and to update their applications. So the way GSLB works is that, as I mentioned, it's DNS-based. So when a client upstream asks the GSLB, give me the IP address for myapp.geo.cf.cs.mobile.com, it's going to provide one of the VIPs on one of these 3 load balancers and then steer that client towards that foundation. This works very well. We set a short TTL of 1 or 2 seconds, so clients that are making new connections are continually querying this GSLB to figure out which pool members are active and where they should be sending traffic. You can also use GSLB to say, for example, if you're originating in data center B, then route traffic to the applications running in data center B instead of sending it across the wire to a different data center over a WAN link. So overall, pretty resilient, it works quite well. We have a number of apps that are very critical using this for all their traffic. However, there are some potential problems. So what went wrong? Shit's on fire, yo. We have this shiny GSLB service that we created. It is very easy to use. CF create service, my GSLB, bind it to an app, bind a geo route. You're done in a minute or so, where you get that traffic being sent to your application. So we developed the service. We advertised it a lot. Customers started using it, which is exactly what we wanted. We had some customers set up an application, and they had clients configured to talk to this application. So as most HTTP libraries do nowadays, persistent HTTP connections is just kind of the norm. HTTP Keep Alive is on by default in most libraries, and it should be because it's much more efficient than standing up and tearing down TCP connections for every single call you want to make. So our clients would query the GSLB, get a foundation to point to, and then establish these persistent HTTP connections where they route the rest of their calls through. So app team decided they wanted to do some maintenance. In this case, they take one of those regions out of load by deregistering the geo route. Persistent connections, unfortunately, don't need to query GSLB anymore. They kept on sending traffic through this persistent connection, which was established to the load balancer, and started sending more calls through it. Because that connection stayed up, the routing layer of Cloud Foundry started reporting 404 route not found, which the customers were obviously pretty confused by because they had the application still running in multiple places. In addition, as they did new tests with curl or with some kind of benchmark tool, all those worked just fine because those new connections were correctly being routed to the active foundations. It was only when we realized it was the already existing persistent connections that were getting 404s that we realized there was a bit of a problem here. So what do we do to actually fix this? Unfortunately, that's kind of the nature of GSLB. It is DNS-based, which has a lot of benefits and drawbacks. So we wanted to make sure our customers were aware of those because if they need to, they can involve other load balancing methods to get traffic to their app. So we improved our documentation, first of all, made sure customers understood how GSLB works and how it is DNS-based load balancing. So if you have an application that incorrectly caches DNS records and does never flush that cache, GSLB is not going to work too well. If you have persistent connections like WebSockets, for example, also not going to work that well. If you have a number of external clients that are all making new connections to your application, GSLB could work great for that. It's a good way to load balance traffic to that application with very little overhead or configuration. So we believe that sharing these kind of problems and information on it is very successful for a partnership, very crucial for our partnership with our customers. So we want to let them know early and often when there is an issue. We also share the incident post-mortem with these GSLB customers so they can understand what broke here, how it broke, and how they can plan for that kind of expected failure in the future. We suggested they actually disable HTTP Keep Alive if they do want to use GSLB and have clients that use persistent connections, because it's just not going to work that well. So instead, turn that off, allow clients to take a small hit to overhead of establishing new connections, and allow them to be able to use this GSLB service. And finally, looking at alternative load balancing methods as well. We're currently looking at using an edge proxy solution using Glue, which is effectively an Envoy control plane. James will now take you through the anatomy of a Kubernetes app that had some issues.
So the first thing is this issue happened while several of us were at the Cloud Foundry Summit in 2019, and the base message here is don't let your tech people travel, because outages seem to happen when they're gone. So the application in question here was one of our first adopters of our Kubernetes platform. It was a team that was running an app and WebLogic on traditional VM infrastructure. And again, this same team had moved some of their other applications to Cloud Foundry, and were really excited to dig into the Kubernetes space. So they did a fantastic job of picking up their app and sort of porting it over to the Kubernetes environment. And they did so kind of on their own, which was great, right? They're a very they're one of our favorite teams in that way, is that they forge a path and they set direction for others, and they're a great partner to work with, because they just not just use the platform, but they collaborate not just with us, but help us be a reference customer for other internal customers about best practices, about what to do, what not to do, and so on and so forth. So anyway, so they picked up this application, moved it to a single Kubernetes cluster, right? So danger right there, running production on a single Kubernetes cluster, but we ported stuff over. They had a mechanism where they could move back to the old infrastructure if needed, if things went wrong. And it turns out that we needed that later on, and it was good to have that in place. So they had an app that was basically a WebLogic app, a Java app running on Kubernetes in, I think, 26 pods at the time on a 24 node Kubernetes cluster. So what do we do as platform admins? What should we be able to do with Kubernetes clusters, right? We want to be able to, one of the advantages of these cloud native platforms is that we can patch and upgrade and do other actions during the day, hopefully, right? So during the day for this multi-tenant cluster, but they were our primarily and our most important app on that cluster at the time, we kicked off a repave to upgrade, I think it was at the time, from Kubernetes 112 to 113. So what happened? Well, our process to upgrade the cluster went very well, and it went very efficiently. The problem was it went a little too efficiently. As it turns out, this application, even though upgrades and restarts of the application had been working fine over time, what we didn't know is that they were kind of slow. And when we went back and looked through, did a postmortem and look back through our emails, we could kind of see the genesis of the problem. And, there were hints there that we probably should have picked up on earlier. And that's something that we are learning from, right? Well, it turns out that their pods took a long time to start, right? So the app team did most of their maintenance overnight. So it wasn't a big deal that a pod took 15 minutes to start. Well, when it became a big deal is when we patched when we upgraded our cluster during the day, and the average node restart time was only about 3 minutes, and it takes 15 minutes for an app to start. You can see the problem, right? Eventually, they started. We moved into the. There we go. So we kicked off our cluster upgrade, which upgraded a max in flight one worker node at a time. As nodes cycled through, the application team began to notice that fewer and fewer of their pods were ready, but the service was still healthy. And this is something we've been stressing to a lot of application teams, right? Is monitor your service, not the individual applications. Well, eventually they got to 0 ready nodes because the cluster finished patching in about 30 to 40 minutes, and some of their application instances had still not restarted, and the bulk of their applications is not restarted. So the app was down, and the initial obvious indicator was what happened with the upgrade. How do we roll this back? Not so easy. We did a lot of troubleshooting, and eventually the short-term mitigation was for them to fail back to their legacy infrastructure via upstream load balancers, while we started to dig into what the actual what the actual root cause was. We also in the early days of both the Cloud Foundry and the Kubernetes environment, we ran a little fast and free with when we did patching. Again, bad attitude on our part in some ways to say like we're trying to build a culture where we can do this work during the day at any time without notifying customers, because that's what the platform's for and how it should be resilient. Turns out that that's not such a great thing to do when you're running a tier 1 app, right? That gets your CIO visibility when it's down for a couple hours during the day. So regardless, say we had to change some of our process past that. So go on to the next slide. All right, so how do we get better, right? So it turns out the root cause of this startup was an entry problem, right? So I don't know if anyone else has hit this, but it's good. It's really good learning. There's a lot of documentation out there. Is that in virtual environments, sometimes you don't get quite the same amount of entropy that your entropy sources are being diverted to other resources or consumed quickly by other resources in virtual environments. So one of the keys there was simply switch the application startup to use dev random instead of dev random, right? We took pod startup from 15 to 20 minutes down to a pretty consistent 4, which means we can that's a healthier application experience for everyone. Our customers, we also work with our customers and set a policy. In the early days, we didn't really understand this as well as we do now, and we probably should have. Is how do we work with our customers to make sure that we can do the kind of maintenance we need to do, but they can be guaranteed that their application can stay healthy through those events. So one of the ways to do that is to set up on Kubernetes, set up pod disruption budgets, right? So that again, that our upgrade process will block on upgrading any individual worker node until if a PDB is not satisfied, right? In this case, they tune their PDBs to be 66% of the ready pods before upgrades, or 66% of the running pods, such that of the now 30 to 40 running pods, right, there can only be 10 to 15 down at any given time, which means that we can do our work, but their platform can be healthy. We're still not doing work during the day yet, which is it's good and unfortunate, right? Our main priority is to provide uptime and keep the business running. This is something we're just about to start readdressing, though, right? Is because I think that everyone wants to be in a position to where we can do work at any time, and that we don't have to burn our people out by working them overnight, right? We have some guys who do a lot of our cluster patching now, and when we have to go through a set of it, right, it's a lot of overnight work, several weeks of it. We have a lot of clusters, we have a lot of environments. It's not ideal, right? So we're trying to move that to a better position. And the other thing we've done is again, better communication with our customers, right? And the mechanism to do that, obviously, internally is change requests. We also proactively blast out on our Slack channel well in advance of any events coming up, any patching events coming up, or any other kind of events coming up. So that's something where it's just make sure that you have good, constant communication with your customers. And the other thing that we do for our internal customers is we don't evaluate things in terms of production and non-production. Everything's production to us, right? All of our customers are important, whether it's just internal developers who are trying to meet deadlines for their project, or whether it's external customers who are interacting with the website to buy or upgrade a phone. So it's nothing is more frustrating to me than hearing someone say, "Well, it's just not production. I don't care." And whenever we hear that, we as a culture on our team, we do not say that. So that's every customer is important to us, both internally and externally. Great. Next slide.
So how do you actually prevent incidents? We talked about some bad things here that get CIO attention. We don't really want that. Short answer is you can't. So what we have done instead is first adopted a policy of radical transparency with our customers. If something is broken, we let people know very early, keep them up to date on everything that's happening, and make sure they know that we're aware of what's happening, that we have fixes for it, and that we will take responsibility when something is wrong. The flip side of that is we assume our customers are right until we can actually demonstrate to them that our platform is not at fault. So when a customer reports an issue, we don't assume it's just the customer being uninformed. We do have customers of all experience level internally. However, we want to make sure that we get to the heart of what's going on, and that we investigate our platform, and don't just assume because we didn't have any alerts or any metrics that are going out of whack that everything is totally fine for us and blame someone else. A big thing that you see at many large corporations is a mean time to blame, where customers that have incidents for their applications want to shift blame to someone else as quickly as possible. we've tried to really not play that game. We don't want to be in a position to try to blame someone else for an issue or to be embarrassed because our platform has a problem itself. If it's our fault, we accept responsibility. If it's not, we demonstrate why and make sure leadership knows as well. We just don't want to play that game at all. So again, when our platform is at fault, we accept responsibility very quickly because we want to fix the issue, explain what went wrong, and talk about how we can try to prevent that in the future. Finally, again, new platforms for our company, a lot of new technologies, new architectures. So when we see customers that are doing things that will get them in trouble, for example, we see customers that log-to-log files in Kubernetes ephemeral containers that eventually fill up their disk, or that have batch jobs running with no way to externalize state. When we see those kind of things, we make sure that the customer knows about it. If they're not listening or don't understand the problem, we let the leadership know as well. And once we feel like we've been heard at an appropriate level, we make sure everybody knows that we are here to partner on a fix. We will help them review architecture, review any kind of changes they want to make, because we want them to be successful on the platform. If their app dies and it's not our fault, it still is a bad look overall to see apps failing on the platforms that our team manages. We really try to avoid that as much as possible and try to partner for success with all of our customers. With that, we're pretty much out of time. We'll go to Q&A on the Slack channels here. Thank you all very much for your time today.
Thank you, Brendan and James. Reminds me of my time running platform teams. I've seen similar issues with slow starting apps, and that was a tutorial on best practices. I want to remind everyone to take advantage of the opportunity to engage more deeply and head over to the Slack channel for a Q&A with Brendan and James.